So, hi guys, we're going to be discussing a CIM concept today known as variation. In this playlist, we'll also cover the AdMath version of it, which is called linear law. But for now, let's stick to variation because it will also it will help us understand the concept a little more in linear law, although it's a little bit different. So, in variation, essentially, it's related to the idea of proportionality. So when you have two variables, if they're directly or inversely linked, they do not have a y-intercept. So why is this? So if you think about a question that might be about it, which would be y is directly proportional to x. Well, that means that when you have the formula y equals mx plus c, in proportionality, it means it has to go through the origin. So that means c is 0. So we can just really write it as y equals mx. But, however, we need to also realize that we need to find m. So it won't be just y equals x if they're directly proportional, because the way we can prove that is if we draw a coordinate plane here, where this is the origin, if it's directly proportional, it could be a line like this. It could be a line like this. This. It could have varying gradients. So that's our responsibility to find out, and that's why we can represent it through m. Typically, this is also represented through the constant k, but you can also use m in this case. Whatever the case, the actual variable you use doesn't really matter as long as it represents the same thing. But variables can also be inversely proportional. In that case, we would write it as y equals m over x, because when it's inversely proportional, it's when x is in the denominator instead of the numerator. So this is directly proportional, this is inversely proportional. And essentially, in directly proportional, when one variable is increasing, the other is decreasing. And in this one, when one variable is increasing, the other is... when one variable... in this one, both variables are increasing and both variables are decreasing at the same time. But in this one variable increases, the other decreases as a result, and vice versa. So now let's look at some practice problems around variations so you get an idea of what exactly it is. Okay, so let's look at this problem here. Y is inversely proportional to the square root of x. When x equals 25, y equals 4. Find y in terms of x. Alright, so the first thing we have to notice is that it says it's inversely proportional. Inversely proportional. So the formula, or the way we will write it, is y equals m over x, where m is a constant that we have to find. And we also have to note that it's saying square root of x, so we have to actually put this in the square root. Let me write that a little bit clearer. Y equals m over the square root of x. And now they give us actually one of the coordinates. When x equals 25, y equals 4. So find y in terms of x. What we have to do is we have to input the values 25 and 4 in here and try and equate it in such a way that, and try and find the value of m that will make this equation actually true, because we are told that it is true. So let's just substitute y equals 4 first, and that's equal to m, which we still don't know, we're trying to find out, over the root of 25, because that's what the value of x is. We can simplify that to make 4 equals m over 5, because that's the square root of 25. And we can multiply everything, both sides, by 5 to get m is equal to 20. So the way we can actually write it, the final way we can write it is y equals 20 over root x. And that's the equation in this case. Alright, so this problem is a little bit different from the previous one, because we actually have an unknown that we're not actually supposed to find. So it says z varies inversely as the square root of w. When w equals a, z equals 18. Find the value of z when w equals a over 9. So it seems that a is a variable that we don't actually need to find, because they're kind of just like inputting it, setting it as an input value, but it's not like it's actually important to evaluate. We have to actually just find z in terms, we have to find w in terms of z, and then evaluate what z is. So the way I'd first write this out is we first know that it's inversely, and it's the square root of w. So that means it has to be z equals m over root w. And we know that when w equals a and z equals 18, it works. So that means that we have to input each value. So it's 18 equals m over root a. And we can really write m, as 18 root a if we multiply each side by root a. So our actual equation for it is z equals 18 root a over root w. But we're not finished there. It says find the value of z when w equals a over 9. So let's input a over 9 in there, which gives us z equals 18 root a over root a over 9, which can equal z equals 18 root a over root a over 3. And we can actually evaluate this now to get z equals 18 root a times 3 due to division of a fraction and that rule over root a. Let me bring this over here because we're going to the answer space, which is 18 times 3 is 54. 54 root a over root a. And how convenient, we can actually just cancel out the root a to get 54. So z equals 54, and that's our final answer. So let's look at another problem here. I think this might be the last one. It's broken down into 4 parts. The fourth part will actually evaluate at the end because it's a little more work than just this. So the first thing we have to do is read part A, because part A will ultimately help us. Well, part A, we have to do that because it'll help us do the rest. So y varies directly as the square of x plus 2. Okay, so immediately we can write down the equation y equals k times x plus 2 squared, because ultimately we have a directly proportional relationship, and it's a square of x plus 2. So when it's directly proportional, we can write k times x plus 2 squared. Or alternatively, like we have been before, we can just write m times k, x plus 2 squared. Now we can substitute the values we've given here when x equals 3, y equals 100. So 100 is equal to m times, and then 3 plus 2 is 5, so 5 squared, which can be simplified into 25m is equal to 100. And if we divide 25 from both sides, m equals 4. So our equation is y equals 4 times x plus 2 squared, which we don't need to simplify. Oh wait, I should have written it down here. We don't need to simplify this any further because it's pretty simplified already. Now, the next part is really easy. We just have to substitute the value of 18 in and then find the value of y. So y equals 4, and then when 18 plus 2 is 20, so we multiply 20 squared, which gives us y equals 4 times 400, and y equals 1600. Yeah, that seems right. And then we have the next part. We'll find the values of x when y equals 25. So it says values because since this is, when we expand this over here, it gives us a quadratic, and that means there are 2 solutions. So the way we can write this is, so when we can substitute 25 in there, 25 equals 4 times x plus 2. Oops, sorry. Let me just write that again. Squared. Then we can actually divide everything by 4 to give 25 over 4 equals x plus 2 squared. I'm not going to simplify 25 over 4 just yet because it's in a fraction and that it can't be simplified further. So we can square root everything to get rid of the squared sign on the x plus 2 side. And the square root of 25 is 5, and the square root of 4 is 2. So we get 5 over 2. 5. Oops, let me just rewrite that. I'll actually rewrite it on the side because it's a bit problematic to write that low. 5 over 2 is equal to x plus 2. And x is equal to 5 over 2 minus 2, which is equal to 1 over 2. So x is equal to 1 over 2. But wait, we're not done there yet. So when we square root anything, there are actually 2 possible answers. There's the positive root and there's the negative root. Because if you square a negative number, it still gives you the positive result. You can't get a negative number as the after you square something, unless it's like a non-real root. So our other solution will be negative 5 over 2 is equal to x plus 2, and we have to solve for x again. So x is equal to negative 5 over 2 minus 2, which is equal to negative 9 over 2. So that's our other solution. Be careful and don't miss that one. The other way we could do it is we could actually just expand these brackets and form a quadratic, which would give us the same answers, but it would be more painstaking. So these are the two solutions, and you can just leave it at that. Okay, guys, so slight mistake. This question is actually a part of the one of the other equation that we got, which I will put on the screen right now. So essentially what we're seeing is that the equation is y equals 20 over root x according to the equation that's on screen. So that means that we have to evaluate this question using this part that we have here. So it says that z is proportional to y plus 2. When x equals 4, z equals 84. Find z in terms of x. So the first thing we got to realize is that we actually need this equation here, because while it says z is proportional to y plus 2, it actually gives us the x values to work with to find z in terms of x. So we've got x in here, so that's good. So the way we write this, since it's proportional, directly proportional to y plus 2, we'd first write it as z equals m or k times y plus 2, and then we substitute y in there. So z equals m times 20 over root x plus 2. And now we can substitute our values of 4 and 84 in here. So 84 is equal to m times 20 over root 4 plus 2, which is equal to 84 plus, and then root 4 is 2, so 20 over 2. So it's m times 10 plus 2. So 12m is equal to 84, and m is equal to 7. So we've got our final equation. Z is equal to 7 times 20 over root x plus 2. And we can leave it like that because it's factored now. But essentially, yeah, that's how it works. So sorry about the confusion, but yeah, that question that we just did, the one before this, was not actually related to this one. It was a one that we did a little bit further back. But anyway, that's how it works. So if you see something that says inversely proportional, I'll just write it as IP, then it's K or M. I'll just write M in this case because I've been consistent with that. M over X. And if it's proportional, I'll write DP, directly proportional. It's MX. Just think of it like the gradient thing where there's no y-intercept because it goes through the origin, if it's directly proportional at least. And yeah, also remember that you have to multiply m by whatever is over here. So like it could be x plus 2 squared, it could be the root of x, and then you adapt it like that, like just like I've done here, where I've multiplied it by y plus 2 in this case. So yeah, that's it for variation. I'll move on to linear law like in my next video. So thanks so much for watching, and let me know if you have any questions.